Hello everyone, let's continue our discussion on the wireless link characteristics. Now, after we discussed about three characteristics different from the wired links, now we will also get familiar with some important parameters in the wireless channels or wireless links. Okay, so we in the wireless links the most typical measures are BER and the SNR. Okay, the BER stands for the bit error rate and the SNR stands for the signal to noise ratio. Okay, so or we can also, I mean, sometimes normally we call it the signal strength. Okay, so basically this is something that if we are closer to the base station or to the access point, then the higher the SNR. Okay, and after we eliminate the noise, of course. All right, so larger SNR is the good thing. Okay, so larger SNR is the better for us. As for the BR is the larger the BR is it is worse. Okay, so we want lower BR. So basically we want low bit error rates. Okay, so let's say now given the physical layer, physical layer, let's say I don't know, let's say specifications. We can increase the power to increase the SNR. Okay, we can increase power to increase the SNR, or we can, let's say, but sometimes there is regulations to limit the power transmit power. So we cannot transmit above that allowed transmit powers regulated by the regulation in some countries. So yeah, let's say the only thing that can influence the CNR is when we are moving closer to the base station or the transmitter, then we can receive the higher SNR. Okay, so the higher SNR, then normally we can have lower BR. Now by the given SNR, and normally what happen is that SNR is something that is given. I mean, we cannot really modify this SNR. We cannot really change the SNR because it really depends on the physical characteristics. Okay, let's say if the transit power is fixed, and then our location to the base station is moving. So when we are moving close to the base station, we receive the high SNR. But then when we move away from the base station, when we receive the lower SNR. Okay, so one requirement is that we have to, try to maintain our system to the minimum required, or the minimum BR that is required, or the maximum BR. Okay, but maximum BR requirements, and this BR requirements is normally set by the device specification. So some device can tolerate the bit error rate up to, I don't know, some numbers, but then above that the error cannot be tolerated anymore. So we have to maintain this maximum BER. Okay, so for example, so now there is other the techniques in the Wi-Fi access points. The latest version, not the latest, but I think starting from 802.11.g, there is this capability of the adaptive modulation and encoding. Okay, and also in the later version of 3G, 4G, and again 5G, then there's also this adaptive modulation. So what happened is, let's say if we are having so for example, we can change the SNR. Okay, let's say first we have higher SNR, so we can use the highest modulation level, so we can get the higher throughput. Okay, but then as we are moving away from the base station, then we receive lower SNR, but then we still have to maintain the same BR, or at least, or let's say better BR. Okay, so what we can do is we are choosing the lower modulation level, so we can still maintain the same the BR required, or we can still meet the BR requirements, and yeah, so that we cannot with the lower SNR, and and so on and so forth. If we are again getting the higher SNR, and we can meet the BR requirements, then we can move also to again to the higher SNR with the higher modulation level. So this is called the adaptive modulation, and we will discuss about this in in the some later in the feature of the 802.11. Okay, now the third characteristics in wireless link is there is additional problems that we sometimes it's called the hidden terminal problem. Okay, so the hidden terminal problem is not really like as is illustrated here. So let's say if there is an obstacle, then let's say terminal C and A cannot be communicated because there's obstacle. But the way we can see it is that simply because uh, between A and C is not in the range of A, and A is not in the range of C. Okay, so they cannot communicate directly to each other. So they don't know if let's say for example A doesn't know if C exists out there, and C is also communicating with B, and C also doesn't know the existence of A, which is also communicating with B. So basically, B and A hear each other, B and C hear each other. So A and B, B and C. Okay, but C and A cannot hear each other. Okay, so they are unaware of their interference at B. So the illustration, I think it is better illustrated with this figure. So let's say A cannot hear C directly because there is signal attenuation. Okay, so it can. I mean, the when it is at B, the signal strength is still good, it's still acceptable. But then when it arrives at C, so the signal strength from A is not acceptable by C, or it cannot be recovered by C. And the same goes also with the signal from C to A. Okay, so now the issue will arise when, let's say, A wants to send something to B, and also at the same time C also wants to send data to B. Okay, so both A and C does not know, they don't know if the existence of each other, so they can transmit the data together, and then as a result there can be some collisions. Okay, so this is beyond the multiple access. So we'll talk about this at the CSMSCA protocol, we just applied in Wi-Fi. Okay, all right. So I think that's it for the wireless characteristic in the second part. We'll continue in the next video talking about the CDMA technology.